Okay guys, we are on set 9 for Tuesday. This is a Texas Tornado Review. So number 1 says, what is the value of the underlined digit in words? Well, let's look at this number first. We have 2 and 571 thousandths. This is our decimal. If we're thinking about money, we're going to cover up that thousandths place. How much money do we have? We have $2.57. Well, the 5 is underlined, and if we have 50 cents, what coin is that? Well, that's the dimes, okay? So we would have 5 dimes. Well, what's a dime worth? It's worth 10 cents. So that's the tenths place, okay? Our decimals here, it goes tenths, hundredths, and this is thousandths. Okay, so it says, what's the value of the underlined digit? We know we're looking for the tenths. We have 5 tenths. This says 500. This says 5 tenths. This says 5 hundredths. So this at least is the decimal. And this says 5 thousandths. Okay, all right. We've got 4 sevenths times 21. We can also look at this as 4 sevenths of 21. Hey, I want us to do the math first. So we've got 4 sevenths times 21 over 1. Why did I just do that? Why did I turn my whole number into a fraction or, oh my goodness, sorry, I just lost the word. I'll think of it later. So we have to turn this into a fraction because we have to be able to multiply it straight across, guys. It's just easier to do this. Oh, rational number. Sorry, that's what I couldn't think of. Okay, so remember, you can multiply straight across, or before you do that, you can look and you can see if you can cross simplify or cross reduce. So y'all can multiply 21 times 4 if you want to, or you can say, hey, can we reduce this at all? Well, all we're doing is looking for a common factor. So does 7 go into 21? 7, 14, 21, it sure does. So that means these two numbers have the common factor of 7. Well, as soon as we find a common factor, we can divide both of these by that same common factor. So if these both have 7 as a factor, then we can say 7 divided by 7 is 1. 21 divided by 7 is 3. So we've done our simplification. So 4 times 3 is 12, and 1 times 1 is 1. Well, what's 12 over 1, guys? It's just another way of writing the whole number 12. Okay, so we know that if we do the math, 4 sevenths times 21 is going to give us 12. Now, if we're looking at the model, we're going to shade this model. Well, we're looking for sevenths. It's telling us that our whole is sevenths. So we have 1, 2, 3, 4, 5, 6, 7. So I'm going to turn this sideways because this right here is one of our sevenths. This is the other seventh, and this is the other seventh, okay? Well, we have 4 out of the 7. So that means I can shade 4 out of my 7. I can shade another 4 out of my 7, and I can shade another 4 out of my 7. And if I add all these up, it should equal 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it does. Okay, so our model matches our math. All right, Jared has 300 bottles to put in cases that hold 12 bottles in each case. Draw a model and write an equation that can be used to find C, the number of cases. Okay, so we've got 300. Actually, instead of a model, let's do our part whole. We have 300 bottles. We're going to put those in cases that hold 12 bottles in each case. So we've got our 300. We know 12 has to be in each case. So how many cases do we need? Well, let's set this up first. What's our whole? Well, obviously our whole is 300 bottles. That's what we have in all. We're going to put 12 in each of the cases, but we don't know how many cases yet. That's what we're solving for. So if we're going to write an equation for this, we know this part whole is addition, subtraction, or multiplication and division. We already know this is division. Okay, so we're going to have 300 equals 12 times C. Guys, I'm going to go ahead and teach you. You need to write this. You need to write this. 300 equals 12. We're going to get rid of the multiplication sign and just put C. Okay, I'm going to go ahead and teach you how I want you to do it in 6th grade. Okay, so here's our equation. Again, kind of the fun way I teach this is, hey, who's hanging out with C? Anytime there's a variable and we're solving for this variable, we want to get it isolated. It has to be by itself. So we're going to say, who's hanging out with C? Well, 12 is, but it's not just 12. It's either 12 plus, 12 subtraction, 12 minus, 12 times, or 12 division. Like it has to have computation with it. Well, what's the computation we know we have when we have a coefficient and a variable and there's no sign? We know it's multiplication. So who's hanging out with C? Times 12. Well, what's the opposite of multiplication? What's the inverse operation? It's division. So we've got to get rid of this 12, and we know if it's times 12, we have to do the opposite, which is divided by 12. So we got to get rid of our 12, and how we get rid of it is we do the opposite operation. So when we do the opposite operation, this cancels out. We are dividing 12 times C divided by 12. That gets rid of our 12. It cancels it out, and we're left with just our variable C. But remember, whatever we do on this side of our equation, we have to do the same thing on this side. Okay, we have to keep it balanced. So we're also going to divide by 12 over here. All right, so we're going to come over here and actually do our division. How many times does 12 go into 3? Well, it doesn't. How many times does 12 go into 30? 12, 24, 36. Well, that's too much. So 12, 24. So we're going to write that above the 2. And 2 times 12 is 24. We're going to subtract. 3 minus 2 is 1. Does our friend need help? Yes. So we're going to have a 0 here. We're going to give our friend the help. 10 minus 4 is 6. Okay. 6 is less than 12, so we know we can bring down our 0. How many times does 12 go into 60? 12, 24, 36, 48, 60. So it goes in 5 times. And 25 times 12 is 60. So 300 divided by 12 gave us 25. So 25 equals C. Well, what did C stand for over in our problem? C stood for cases. So how many cases do we have? We have 25. Okay, so C equals 25. All right, so that's how to do it algebraically. You might as well learn it that way because that's what you'll be doing next year. All right, we have, what is the volume of this rectangular prism? Okay, well, we know we have a couple different options for volume. We can do base times height, or we can do length times width times height. These are our 2 formulas we can use. Well, when we're looking at this picture, we don't have a base yet, but we can count our blocks. So we've got 1, 2, 3. So we have 3 blocks for our width or our length, however you want to look at it. 1, 2, 3, 4, 5, 6, 7. We have 7. And then we've got to do our height, which is 1, 2, 3, 4. So right now we're going to use this formula because it makes more sense because we've got our 3 numbers. So we got volume equals length times width times height. I want to go ahead and solve it with y'all because that's the fun of it. So let's write it on our board so it can be a little bit bigger. All right, we have volume equals length times width times height. Now, we don't have our volume, so we write down our V. We've got our length is 3. Our width is 7. Our height is 4. Okay, so we're going to keep going. We're going to do this first, just like a PEMDAS. We've got 3 times 7 is 21. We've got our times 4 left. So we're going to come over here and do our 21 times 4. 4 times 1 is 4. 4 times 2 is 8. So we've done this now. And our volume equals 84. Okay? It didn't give us inches or feet or centimeters. It didn't give us a unit of measure. Okay, our equation was volume equals 4 times 3 times 7. But since we solved it, we're going to write it. Okay, it's 84. Let's go ahead and say inches. And that way we can say inches cubed. We can have a label on it. All right. It says plot point C at this location. So we've got our X and our Y. And this time we have fractions, guys, and that's really cool because we haven't really done those yet, okay? Or a lot of those anyway. So we look down here at our coordinate grid, and we've got a 0 here and a 1 here. So this is a one whole number, which means this has been divided into fractions. Well, if our denominator is a 5, then this should be divided into fifths. So let's look. 1, 2, 3, 4, 5. It sure is. So that means this is our 1/5. This would be our 2/5. This would be our 3/5. This would be our 4/5. And our whole number would be our 5/5. Remember, when our numerator and denominator is the same, that equals 1. That's our super 1, remember? So again, if we're going to plot this, we're always going to start at the origin. Let's make sure our Y is also cut into fifths. 1, 2, 3, 4, 5. It is. So let's go ahead and label these two. We have 1/5, 2/5, 3/5, 4/5, and this would be our 5/5 again. Okay, so we're going to start at the origin. We're going to walk to our 1/5. We're going to fly to our 3/5. 1, 2, 3. And that is our plot for that coordinate pair. All right, we're going to do some multiplication. We've got 6 times 3, 6, 12, 18. Carry the 1. We've got 6 times 2 is 12, plus 1 is 13. Carry the 1. 6 times 5, 6, 12, 18, 24, 30, plus 1 is 31. We cross this out, we add our 0 placeholder. 6 times 3, 6, 12, 18 is 18 again. Carry our 1 again. 6 times 2 is 12, plus 1 is 13. Carry the 1. 6 times 5 is 30 plus 1. Since we had the exact same number, these should be the exact same number. So we have 3,138. We do have the exact same numbers plus our 0 placeholder. So now we're adding. We've got 8. We have 8 plus 3. 8 plus 2 is 10, so 8 plus 3 is 11. Carry the 1. 3, 4, 5. 3 plus 1 is 4. 3 plus 1 is nothing. 3 plus nothing is 3. We don't have any decimals in our numbers, so we just count back 3. 1, 2, 3. We put our comma, and there's our answer. All right, we are going to divide our, we've got a decimal in our dividends. We want to float the bobber, so we're going to float that thing to the top before we even start. We're going to look at our number. We're going to round this. Is it closer to 20 or 30? Well, it's 26, so it's going to be closer to 30, so we're going to put our little 3. Remember, that's our little friend if we need it, okay? So we ask ourselves, does 26 go into 1? It doesn't. Does 26 go into 12? It doesn't. Does 26 go into 127? Well, we know it does. So we're going to come over to our little friend, and we're going to go about how many times does 3 go into 12? Well, 3, 6, 9, 12. It goes in 4 times. So this is the number we're going to start with. This is the number we're going to multiply by our divisor first to see if that's what we need. So we can come up here and let's do, or I'll come down here. We'll do 26 times 4. 6 times 4 is 24. Carry the 2. 4 times 2 is 8 plus 2 is 10. 104. Okay, is that what we need? Well, we might be able to get another 26 in there, so let's just add 26 really quick just to make sure. We've got 6 plus 4 is 10, 3, 0. That's going to give us 130, but guess what? That's too much. So our little friend was exactly right, okay? This did not go in. 26 did not go into 12. Sorry, guys, I forgot to have you put your 0 there. You definitely have to put your 0. Now, 26 went into 127 4 times. It equaled 104, so we're going to write our 104. We've got 1 minus 1 is nothing. 2 minus 0 is 2. Does our friend need help? No, so we just write our 2. 7 minus 4 is 3. We check and make sure our subtraction is less than our divisor, and it is, so we can bring down our 4. This is kind of a big number, so we go back to our little friend and we say, about how many times does 3 go into 23? Well, 3, 6, 9, 12, 15, 18, 21, 24. So it's going to be a 7 or an 8. So let's go ahead and try 7 first. So 26 times 7, 6 times 7 is 42, carry the 4. 7 times 2 is 14, plus 4 is 18. That's only 182, so I bet we can get another 26 in. So 6 plus 2 is 8. 8 plus 2 is 0, or it's 10, sorry, carry the 1, and this is 208. So wow, we might even be able to get in another 26. So let's try. 208 and 26 is 14, carry the 1, 3, and 2, and that's the number we wanted. So guys, we multiplied by 7. We only got 182. We added another 26, so that would be 8. We added another 26, so that would be 9. So we actually multiplied this by 9 to get our 234. And that is our answer.